right, everybody, welcome. It is question 18. What is the solution to the inequality 2x minus 7 is greater than 2.5x plus 3? Treat this just like an equation. So I'm just going to rewrite everything just like I normally do so we can start fresh on the bottom over here. And the first thing I want to do is isolate this. And this is just my choice. You can do this 7 too if you want, but I just want to isolate this real quick. So I'm going to go ahead and subtract 2.5x from this side and put it over here on this side, which this is going to give us now a negative 0.5x minus 7 is greater than a positive 3. So I'm going to go ahead and I'm going to get rid of all this junk up here. I'm going to move this up so we can work on it again. Now I'm going to go ahead and I'm going to move this 7. So to get rid of a negative 7, we have to add 7 to both sides. It gets rid of this. And it still leaves us with our 0.5x is greater than now 10 because we do 3 and 7. Now, one of the things you have to remember is when you divide or you multiply by a negative, you have to flip your sign. All right. So our final answer is going to wind up being x is less than negative 20. If you put this in your calculator, you're going to wind up getting this answer right here of negative 20. So we're going to go up, and our answer is going to be choice 4. That's it. All right, everybody, welcome to question 19. So 3 expressions are written below. We have A, 2xy squared cubed, B, 2x cubed, y to the 6th, and C, 2x squared, y squared times 4x, y to the 3rd. So the best way to do this is just to carry this math out and to actually do the math. So when we see something that is outside of parentheses, it tells us how much inside the parentheses we have. So we're going to go ahead and expand on A by doing 2xy squared 3 times. So 2xy squared, then we'll do another one. And then all we're going to do is multiply these numbers on the outside. So 2 times 2 does give us 4. And then times another 2 does give us 8. And when we multiply, we are going to add our exponents. So we have 1, 2, and 3 x's. And then we have 2, 4, and 6 y's. So this one works out. We're going to give it a blue check. Let's move on to the next one. We're going to move on to B. So B is going to be 2x, 2x, and 2x with a little y on the 6, y to the 6 by itself. Again, we already know when we multiply 2 times 2, it gives us 4. Times another 2, it gives us 8. And then we have 1, 2, and 3 x's. And then we're just going to move this y to the 6 down. So this one works as well. And we're going to move on to the next one, which is going to be C. And we're going to have 2x squared, y squared, times 4xy to the 3rd. Now we know that when we multiply again, 2 and 4 does give us 8. And then we're going to add our x's. So we have 2 here, and we have 1 here, which does give us our 3. But we have a problem with these purple boxes. A 2 and a 3, in fact, gives us y to the 5th, so it doesn't work. So our answer in this case is going to be A and B only, which is choice 1. All right, what up, everybody? Question number 20. We pulled this annual compound interest right here. We pulled that from the reference table that you're going to get. So we're just going to go through it real quick. A represents, obviously, the annual compound interest. P represents the principal amount. So the principal balance or the deposit. So remember that. If you need to take notes, write this down. It's the principal balance or the deposit on that. Then the R represents the rate, which we'll usually see it in a percent, but it's in the form of a decimal. That's how we have to work with it. So in a decimal form. Give you a couple seconds. And then our N is going to represent a variable that we might not know. The number of times that this compounds annually or over a certain amount of time. So number of times we'll say compounded. Right? So we're going to go ahead after we erase this. We're going to rewrite our stuff down here. A is equal to, our initial balance is going to be $4,000 with 1 being carried down from the formula plus our rate, which again, we see our rate is 3%, but to show it as a decimal, it's going to be 0.03. So plus 0.03. And we do not know how many times this compounds. We're not looking for that, so we're just going to replace our n, in this case, with an x based on our choices that we have. So I'm just going to go ahead and just kind of bring this all together. A is equal to 4,000, 1.03 x, and that's going to be our final choice or our final answer. So we're going to take a look up here and see which one looks like that. And we're going to go ahead. It is going to be choice 4. There you go. Perfect. Use the formula. Don't stray away from the formula, and you're good to go. All right, everybody. This is question 21. When factor completely, negative x cubed plus 10x squared plus 24 is one of these 4 choices. First thing I like to do is find the factors that are going to add up to this number here and multiply to this number here. So we really just have to find factors of 24. So I'm going to, over here on the side, I'm going to find the factors of 24. So we're going to list them. 1 and 24, 2 and 12, 3 and 8, and then 4 and 6. Now we can get rid of some of these because we need it to add up to this middle term right here and multiply to this term outside here, the third term. So to do that, we know we're not going to be able to get there from 1 and 24. So we're going to get rid of 1 and 24. And we can't get there with 3 and 8. So we're going to get rid of 3 and 8. So that leaves us with either 2 and 12 or 4 and 6. So we're going to keep messing around until we get there and see. So the first thing we're going to do is rewrite everything. Like I always do, x cubed plus 10x squared plus 24x. The common term or the common variable in all 3 of these terms is the x. So we're going to pull out a negative x, which is going to give us x squared minus 10x minus 24. Now we can make a decision on what number we're going to use. We can get to both. We can get to negative 10 with 4 and 6, but we can't get to negative 24. So we're going to get rid of that, and we're going to live with 2 and 12. So we're going to use the parentheses like we did earlier. Put x's in there. I'm just going to carry down this negative x. And we're going to put 2 in this first box and 12 in the next box. Now we have to get our goal is to have it be negative 10 when we add it together and then multiply out to a negative 24. So for me, that means that our bigger number needs to be negative and our smaller number needs to be positive. So if that's the case, when we go up to our selection up at the top, we're looking for not 4 and 6. We can get rid of 1 and we can get rid of 2. And we can talk about either 3 and 4. So we're looking at our answer, which is going to be choice 3. All right, everybody, welcome to question 22. The problem involves converting speed given in kilometers per hour to feet per second. So the conversion factors required for this transformation are the following. I'm going to give you a little bit of information. We can get this all from the reference table that they give you for the Algebra 1 Regents, but it's 1 kilometer, which is equal to 0.6211371 miles. And then we're going to also need to know that 1 mile is equal to 5,280 feet. We're then going to keep going and we're going to say to ourselves, we need to know that 1 hour is equal to 60 minutes. And then 1 minute is equal to 60 seconds. So we need all this information right here. Now, we're going to go ahead and just get rid of all this stuff. I'm just going to go ahead and explain to you what the vibe is here. So the correct conversion sequence to go from kilometers per hour to feet per second is to convert the kilometers to miles. Kilometers to miles. All right, that's the first thing. And then hours to minutes and minutes to seconds. So the process should look just a little bit like this. We're going to convert the kilometers, which is our guys right here. We're going to multiply by the factor, which we already know is this right here. And then that's going to give us the multiplying by 5,280, which we know is how much is in 1 mile, for a foot is in 1 mile. And then we're going to keep going. We're going to convert the hours to minutes. And then we're going to go ahead and we're going to convert the minutes to seconds. Now, if you want to know a little bit further and deeper into this, you can go ahead and I'm going to lay something out for you so you guys can see a little bit of what the vibe is here. So we have kilometers over hours times miles over kilometers times feet over a mile times an hour over a minute times a minute over a second. Now we're going to get rid of some stuff. What cancels out? Kilometers and kilometers, miles and miles, hours and hours, and then minute and minute. This is correct because it leaves us with what we're looking for, which is the conversion of feet per second. So our answer is going to be 2. All right, everybody, welcome to question 23. So boom, the zeros of a polynomial function are -2, 4, and 0. What are all the factors of this function? So the first thing that we have to do, I'm going to drop some knowledge on you. The zeros of a polynomial function give us the values of x for which the function equals 0. So when the function equals 0, that gives us the values of x. So it gives us the values of x, or the value of x. All right? So when the function is equal to 0, it gives us the value of x. So write that down if you need to write that down. The zeros that we have that we're talking about are going to be highlighted right up here. And I'm going to rewrite them. -2, 4, and 0. So when we say x is equal to 0, really what we want to say is x is equal to x minus a. So now we're going to then plug these zeros into this equation right here, and it's going to give us our factors of this polynomial. So x is equal to, forgot the parentheses, x minus a -2, which we know is equal to x plus 2. So that's one of our factors. X plus 2 is one of our factors. I'm just going to plug that up right here. We just found that factor. Now, I'm going to go ahead and I'm going to plug in our next factor, which is going to be 4. So x minus 4, which that's one of our factors. We don't have to do anything with it. We just carry on. So if we did plug it in like this, we would just distribute and it would still be this number right here. So we don't need to do that. Get rid of all that stuff. So one of our factors is, in fact, x minus 4. And then the last one that we're going to do is we're going to plug in the 0. So x minus 0. And we already know that that leaves us with x. So that's another one of our factors. So now when we scroll back up here, we're looking for x plus 2, x minus 4, and x, which is this choice, number 3 here. All right, everybody, welcome to question 24. This question right here looks a little daunting, but it's really not as bad as you think. So the function provided is f of x. So we have f of x is equal to x minus 4 squared plus 1. So to find the range, we need to understand how the function, this function here, behaves, excuse me, as x changes. So the term x minus 4 squared is a squared term. X minus 4 squared is in fact a squared term, which means that it will always be positive. So it's always going to be positive. So if we know that, let's write it down, always positive. And it will always be a positive or 0, all right? Because squaring any real number cannot give a negative result. Again, the term x minus 4 squared is a squared term, which means it will always be positive or 0 because squaring a real number cannot give a negative result. So the smallest value of x minus 4 squared is 0, which occurs when x is equal to 4. When that happens, the whole function simplifies to f of x is equal to 0 plus 1, which is equal to 1. Since we know that x minus 4 squared is never negative, the function f of x is always going to be 1 or more no matter what x is, so 1 or more. As x moves away from 4, either less than 4 or greater than 4, x minus 4 squared gets larger and so does the f of x. Therefore, the smallest value f of x can take is 1. And there is no upper limit to the values f of x can take as x becomes very large or very negative. Thus, the range of f of x is greater than or equal to 1, which gives us our answer of 4.